Hello everyone. Today we will look at the first two problems of Leetcode Weekly Contest 413. The first question is check if two chessboard squares have the same color. So we are given a chessboard. Basically we are given the two coordinates of the chessboard and this is just a pictorial representation of the chessboard. So for example we are given A1. So what is A1? A1 is this square and let's say the second coordinate is d2. So d2 is this square. Since both of these squares have the same color, we have to return true. Similarly, let's suppose if we are given b2, so b2 is this, and let's say we are given e4, so e4 is this. Since for b2 and e4 the colors are not same, we will return false in this case. Now this question is a bit easy if you want to brute force it, since the chessboard is constrained to be a 8 cross 8 grid. What we can do is we can make a 8 cross 8 vector and then just fill up the colors. So let's say we create a vector of 8 cross 8 int. So what I mean is we can create a vector of size 8 cross 8 and then this, this will be a vector of int. And if you are not from C++ background, I mean you can create a vector of size 8 cross 8 and the vector is of type int. And if vector of ij equals to 0, then it means it's white, and if it's 1, then it means it's black. And similarly we can fill this vector with either 1 or 0 depending on the color of the square. And then whenever we are given the coordinates, let's say a1, then we will map it to vector and see. So now how will you map a in the vector? So we will just convert a into 1, b into 2, c into 3, d to 4, e to 5, f to 6, g to 7, and h to 8. So a means 1, b means 2, c means 3, and so on. So a1 will means 1 1. So we'll check whether vector of what, and let's say second coordinate is e2, then e2 will mean 52. So we'll just check whether, let's say this vector is v, so we'll check whether v of 1 1 is equals to v of 5 2. Now it's a brute force solution, since uh, it will pass, but let's say let's suppose instead of 8 cross 8 we are given a n cross n. In that case, what would be the time complexity of this solution? It would be what? Time complexity would be what? O of n square. Why? Because we are constructing a n cross n grid and then filling it up. And space complexity would be O of n square. Right? Because we are using a grid of size n cross n. But can we do better than this? Let's see. Now, okay. So if you would notice, you will see there's a pattern in there. And what's the pattern? Let's say this square starts with a black color and then the color alternates. Similarly, this square starts with a white color and the color alternates. And same, now this starts with a black color and the color alternates. So we know that there is some pattern in that, but what's the pattern? Now, for finding the pattern, this mapping is very important. Now, let's see what we can, if we are able to find some pattern in here or not. Now, let me just change my pen color. Now, let's say A is 1. So, if we are given A1, A1 is 1 1, A2 is 1 2, A3 is 1 3, and A4 is 1 4. Now, it's black. Now, it's white. 1 3 is black and 1 4 is white. Can you see some pattern? If both are odd, then it's a black color. And if one is odd, one is even, then it's a white color. One is odd, both are odd, it's black. And one is odd, one is even, it's a white color. So we see BC3 patterns. What if both are odd and odd? Then it's a black color. If one is even and the other is odd, it's a white color. And if the first is odd and the second is even, then again it's a white color. Okay, but is this pattern true for everywhere? Let's see. 3 1, both are odd and it's a black color. 3 3, both are odd, it's a black color. Same, both are odd, it's a black color. Now 3 2. Okay, so for 3 2, what we can see, one is odd, one is even, it's a white. One is odd, one is even, it's a white. And this pattern holds everywhere. Now, but we are missing one case. What about if both are even? So let's consider this. 2 2, it's a white. 2 4, it's a white. 4 1, it's a white. So sorry, for 2 2 it's a black, for 2 4 it's a black, for 2 6 it's a black, for 2 8 it's a black, for 4 2 it's a black, for 4 4 it's a black, for 4 6 it's a black. So if both are even, the color would be black. And that's all we have to do in this question. So we are finding the coordinates first. So if it's a1, then we are converting a into 1 and we are mapping a with 1, b with 2 and so on. So now this is for the first square, this is for the second square, and now we are checking if the first square are both odd or are both even, then that means the color will be white. So if both are odd or if both are even, then c1 will be 1, otherwise c1 will be 0. Similarly for the second square, if both are odd or both are even, then c2 would be 1, otherwise c2 would be 0. And if both c1 and c2 are equal, that means both the squares have the same color. And if we run this, if we submit this solution, it will definitely pass. We are given an infinite 2D plane, and we are given a positive integer k, and we are given a 2D array queries. Okay, query of I is of type x comma y, where x comma y is the coordinate of the point in that plane. After each query, you need to find the distance of the kth nearest obstacle from the origin. If they are less than k obstacle, then you have to return -1. Otherwise, you have to return the kth nearest distance. Okay, and distance is defined as absolute of x plus absolute of y. Okay, so what's this question all about? So it's saying that we have an infinite 2D grid. Okay, and let's say we are given lots of points. Some points are A, some points are A, some points are A, like this. Now the distance of this point from the origin is absolute of x plus absolute of y. So let's say these are pi. So distance of pi is absolute value of xi plus absolute value of yi. Okay. And how these points are given? These points are given in a query vector. So this is our query vector. Now let's say the point is 2 comma 3, 4 comma 5, -1 comma 0, and so on. Now we have to return the kth smallest distance for each query. Okay, kth smallest for each query. But no, so now we have three questions to ask. What if we have less than k points? So in that case we have to uh, so in that case the answer for that query would be -1. So if we have k query, or let's say for each query we have to return an answer, so we have to make a vector of results. Okay, now if we have processed less than k query, that means we have less than k points. So until that point our answer would be -1 always. Okay, now once we have processed k points, now that means we have k distances, and the smallest of them we have to answer. So that's the question. So let's take this example. K is 2. So we have to tell the second nearest. Second nearest means second smallest distance. So when we process 1 comma 2, the distance is 3, but we have only 1 point. So in that case, answer is -1. Now the second point, distance is 7. Now we have two distance, 7 and 3. Since 7 is the second smallest, so 7 is the answer. Then we have 3 comma 2 5. So 3 5 7. We have 3 distance and we have to tell the second smallest. So that is 5. And then it's 3. So now second smallest is 3 because we have 3 3 5 7. So second smallest is 3. So we return 3. That's all. Okay. So it's clear when we have less than k points, it's -1, and whatever distance we have processed, we can store it in a vector, all of the distance, and we can sort this. After processing each query, we can sort this distance, and whatever would be the smallest, that would be that result of, let's say this is our distance array. We sort this, so result of I would be what? Distance of 0. That's all. Now that's a brute force approach. So the time complexity would be O of n. Why? Because we are processing each query only once, and the space complexity would be also O of n. Now let's first see this in code, so that would be more clear. So let's just forget about this solution for now. So what are we trying to say? We need to make a vector of distance, and then we have to make a vector of answer. That is our result that we have to return. Now we will process all of the queries. So for int I equals to 0, I less than queries dot size I plus plus. What would be our first point? Okay, so our x would be queries of I 0, and our y coordinate would be queries of I 1, and our distance would be what? Absolute of x plus absolute of y. We would push this distance into the vector. Okay, let's call this. Okay, now if the size of distance is less than k, if the size of distance is less than k, that means we don't have k points. So in that case, our result would be -1. So we do result dot pushback -1. Else we would sort the distance array. Okay, and we have to find the kth smallest. So kth smallest would be result dot pushback. It would be at k -1. So this of k -1, and finally we would just return this return result. Oh, why it's giving wrong answer? -1. Oh, it would be distance dot end, not begin. And let's submit this. Okay, we are getting time limit exceeded. So can we optimize this? Let's see. Now at each stage, what we are doing. So in the previous approach, what we are doing, we are running this for loop n times, and then we are doing sorting. So it's n log n. So it's actually n times n log n. So our time complexity is n times n log n. That is n square log n. Can we optimize this? Why we need to sort every time? So if you have solved a question called kth smallest element in the array, you know this question can be solved using min. Sorry, if this is the smallest, then we need max it. And if you had asked kth largest element in an array, then that can be solved using min. And in this question, we have to find kth smallest distance. So we are getting the intuition that we need to use heap somehow. And if you've never heard of this question, I would suggest first looking at the problem and trying to solve this problem using heap. So what's the approach for this question? I'm not going to explain this approach in detail, but what we do is if you have to tell kth smallest element, then we make a heap of size k. So we make a heap of size k, and we first put k elements in here. And so let's say this is our array and our k is 2. So we first make a heap of size 2 and we put the elements in that. So this our heap would look something like this. Let's say we have 3 elements, and then we process the remaining elements one by one, and we insert one element and remove one element. So at the end our heap is of size k, and at the end whatever would be the top element of the heap, that would be our answer. Now what are we doing here? We are storing distance every time. So what we do, we just store this distance instead of a vector. We will store this distance into a heap. Okay, and whatever would be the top element of the heap, that would be what, our kth smallest element, if the heap is of size k. So now again, if our heap is less than if the size of the heap is less than k, then that means we haven't yet processed k elements. So in that case we would the result of I would be -1. Otherwise the result of I would be the top element of the heap. Okay, so we just make a max heap, and then this is our vector of answer that we have to return, and we are processing each query one by one. We are calculating the distance and then pushing it into the heap. If the size of the heap is greater than k, then we will port the elements until the size of the heap is if less than or equals to k. And if the size of the heap is less than k, then that means we haven't yet processed k elements, so we will push back -1. Otherwise, if the heap is of size k, then that means the top element would be the kth smallest element. So we'll push the top element and finally we'll return the answer.